5.1, part 2. We are solving trig equations.
Do we still use them?
Now, as we are solving these trig equations, I guess I should have, before we started, asked you to have something out. But, yes, you're still going to be using our trig identities. Those are still going to come into play at times, okay? However, you also might want to have your unit circle out. Chapter 4 knowledge and the unit circle is back. Okay? So, should have said that before we started, but I kind of forgot. Okay, we have quite a variety of equations to solve today. So are we finding our unit circles? With the first one, we start very basic. Okay, we start very basic. And they ask us to solve sine of x equals 1/2. Now, in all reality, there's not any true solving on this equation in terms of like adding, subtracting, multiplying, dividing. It is more of a, okay, what values of x, what values can we fill in for x that will make it true? Okay, so, and this is kind of a combo of looking at your unit circle and looking at our reference chart. Okay, now you will notice that we are solving these equations on the interval 0 to 2 pi. Now, in our notes, it has a bracket on 2 pi. Technically, it'd be a parentheses. If you think about it, 0 to 2 pi is once around the circle, yes? But 0 and 2 pi are the same thing. So we'll use 0. We don't actually use 2 pi there. And so, on this first one, our goal is at what point does sine equal 1/2? So I'm looking for at what angle does sine equal 1/2?
Not pi over 2 is 1/2.
No. At what angle does sine equal pi over 2? Or, no. 1/2. You said pi over 2. My brain is on pi over 2 now. Now, here's the deal. I will tell you that sine of pi over 2 is actually 1. So if this said, at what angle does sine equal 1? Then the answer would be pi over 2.
Oh, wait. So, wait. Sine is the y value, right?
Yeah, that's fine.
Don't think in terms of that. Okay. Here's my hint. Let's look at our reference chart. At what angle does sine equal 1/2?
30 degrees. 5 or 6.
Okay, we're gonna go radians.
Yeah,
Okay, I agree, it is 30 degrees. Not gonna argue, but pi over 6. So one of our answers is pi over 6. I mean, one of our answers is pi over 6. Okay, so as I said, we are going to eventually use our identity somewhat. We want to have those available, but we're not going there yet. Okay. So now, when else does sine equal positive 1/2? And this is where, on our reference chart, those are the quadrant 1 answers. Okay, those are the quadrant 1 answers. There's 4 quadrants though, because we're on the interval from 0 to 2 pi. So what other quadrant do we want to consider?
Yeah, 5 pi over 6.
Why 5 pi over 6?
Because it's in the sine quadrant, like the positive quadrant, and then it's also like pi over 6 away from. I don't even know what I'm saying.
Yeah, you're right. Pi over 6 away from the x-axis. Okay. So all students take calculus. Okay. In these bottom 2 quadrants, sine would equal negative 1/2. So forget those 2. We already have the quadrant 1 answer. In quadrant 2, sine is positive. So at what angle does it equal 1/2. Well, as Logan mentioned, this is pi over 6 up from the x-axis. So what is this if it's pi over 6 up from the x-axis? And that is 5 pi over 6.
I'm just saying, both those answers, the y value is 1/2. Just saying.
I wasn't thinking, okay, valid. I wasn't thinking that way. I see what you're saying. Okay, it would. It would. Okay, now, here's the deal. Okay, when you guys asked earlier, it's just the sign is the y value, right? I wasn't thinking about the ordered pairs on your unit circle. I don't know, my brain went a different direction. It was confused, just, I'm with you now, okay?
Yeah.
So, yes, that does help. Now, and if you look at the pi over 6 angles in the bottom quadrants, they're negative 1/2, right? Now, I don't want you guys relying on that, though, because you won't always have this unit circle with these lovely XY ordered pairs provided. Fair enough? So we've got to know how to rationalize through it without relying on the unit circle. Okay? Okay, now, in this case, there are 2 answers. Folks, we could have 1 answer today. We could have 2 answers today. We could have 4 answers. It just depends on the problem. Okay? I'm not going to say there couldn't even be more than 4.
That's not good.
Okay, so it's just going to depend on the problem. Now, and note, what did we do there? We used our unit circle and the trig chart for our values. So that is the note I'm going to put here is to, we're going to be checking the unit circle and our trig chart for values. So that's why you're going to want to have those out today. Okay? Okay. That's our basic starter. Now, number 2. We could just jump right into this and say, okay, at what angle does cosine, when you add 1 then to it, equal 0? Or we can do a little bit of basic solving. Normally when we go to solve an equation, we try and get our variable by itself, yes? So in this case, it's not just about getting our variable by itself, but getting the trig function by itself. How do we get the trig function by itself?
You subtract 1.
Okay, just like basic. Subtract the 1 over. And then we end up with cosine of x equals negative 1.
So I don't know if this is the right train of thought. But going with the x and y's, the x value is cosine. So therefore, the x value would be negative 1 at 180 degrees. I agree.
Are you guys on your unit circles? Right? Because that is exactly what we need to look at, is when does cosine equal negative 1? So remember how I would always say, okay, think about the ordered pairs. This is 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1, yes? So there's your ordered pairs. So now when we talk about zeros and ones, unless it's a tangent, we're usually talking about our quadrantals, right? So the 0, if I go degrees, 45, 180, excuse me, 0, 90, 180, 270. Okay. I also agree, it's cosine, comma sine in an ordered pair. We're looking for when does cosine equal negative 1. So that is there. Now, Logan said 180.
Pi.
I'm going to write pi. Does it happen anywhere else?
No.
So x is equal to pi. And we have just the one answer. Okay? Questions on that one? Start looking at number 3. Cosine squared x plus cosine x minus 2 equals 0.
What if we added the 2 across and then took out a cosine? I don't know if that would do anything.
It doesn't do anything helpful.
Yeah, so like how would you?
Oh, no.
What do you
I'm just shooting here.
I agree. Throwing out the ideas. I mean,
2 for 3 right now. That's a good percentage when you're shooting.
okay.
When you're shooting, yeah.
Well, here's what I'm going to say, is I do like this equation being equal to 0 because I see an x squared in there, essentially.
Wait. We know that. Never mind.
Here's going to be my suggestion for this problem. I want you to think about this problem as if the cosines weren't in there. Okay? So what I want you to think for the moment,
Okay, so this was.
okay, so we're going to think as if the cosines aren't in there. So if I delete the cosines, this is what? X squared plus x minus 2 equals 0, correct?
It's a factor.
How would you solve the equation that is x squared plus x minus 2 equals 0? You would factor, yes? Like unfoil it into 2 parentheses?
Yeah.
Just think basic algebra. This like takes us back to algebra 2, but it also takes you back to algebra 1. Okay, so we're going to think for a moment. We're going to go back to cosines here in a minute. But I have to have you guys to the point where you understand it without the cosines. So, if this was just the basic algebra equation, x squared plus x minus 2, you'd use 2 parentheses, right? X squared would break into
X.
x and x. What numbers multiply to be 2?
2 and 1.
And how do my signs work? To multiply to be negative 2 and add to be 1.
What the heck?
Hang on.
If it multiplies to be negative 2, I need a positive and a negative.
Oh, positive 2. Negative.
Have we not done enough factoring this year? At least not lately.
Four.
Okay,
Everybody else can step
Now.
up too, you know. Looking at that answer.
are we good with that basic algebra?
Plus,
Okay, now, we're going to go back, and instead of just doing the basic x's, these weren't basic x's, they were actually supposed to be cosine x's. So we're going to go here, and we're going to do this with trig now. We're going to factor it into 2 parentheses. X squared normally breaks into x times x. So what's cosine squared x going to break into?
cosine X.
Cosine x times cosine x. What numbers did you already tell me multiplied to be 2?
2 and 1.
That was 2 and 1.
Plus 2 left.
And we talked in order to get them to multiply to be negative 2 and add to be this positive 1 is a plus 2 minus 1. Okay? So that's, I need the cosine x's back in there because we're going to continue solving. Now, we have 2 parentheses multiplying to equal 0. What's our normal next step? If I was up here at x plus 2 and x minus 1, you take each parenthesis, each factor, and set it equal to 0, yes? So that means in this case, I'm going to say cosine x plus 2 equals 0, or cosine x minus 1 equals 0. Okay. How do I solve these?
You cosine equals 0 for 1. get cosine by itself.
Okay, normally we'd say get x by itself. It's going to be get cosine by itself. So on cosine x plus 2, I'm going to subtract 2. So cosine x equals negative 2. On cosine x minus 1, we're going to add 1. And cosine x equals 1. Now, do these look like problems 1 and 2 that we already did today? Same idea, yes? You're asking now, we're solving 2 equations essentially. So we're going to ask ourselves, at what angle or angles does cosine equal negative 2? And at what angle or angles does cosine equal 1?
Well, 1 is just 0, right?
Okay, are you guys with them? Go back up to, and it's not on this screen for me, but when does cosine equal 1? Guys, why did I flip back to this screen? When does cosine equal 1? Right there at 0 degrees, yes? I just didn't want to redraw this, I'm being lazy. Does cosine equal 1 anyplace else? No. 0, negative 1, 0. Okay, so that is at 0 degrees or 0 radians. So in this answer, we can say 0. And that is the angle of 0. Okay? Now, what about cosine equaling negative 2?
You just go like another rotation from negative 1.
Like another rotation around the unit circle?
Yeah.
Another rotation around the unit circle, those values are still going to be the same though.
Yeah.
They don't change. Okay, so looking at the quadrantals, those were all zeros, ones, negative ones, right? So was it happening at any of those? No. Looking at the unit circle, does it happen anywhere there? Or that's not the unit circle, that's our trig chart. Looking at our trig chart, does it happen anywhere there?
No.
No. Okay. When we did cosine graphs, and I know you've already long, just think about it. The basic cosine graph. How high and low did the basic cosine graph go?
Right, the amplitude was
Right, but if there was no amplitude,
1.
it's just a basic 1, right? It went up to 1 and down to negative 1. When is it going to go down to negative 2? The basic cosine isn't going to go down to negative 2. Now, if there was an amplitude of 2, sure, we could talk then. But this is just the basic cosine. So this one, cosine's not going to equal negative 2. That particular answer is actually not possible. Okay? Now, I'm not going to say no solution, though, because did we still have a solution on the other piece? Okay, so that's why you didn't see me write no solution.
Would just be x equals 0?
Yeah, so you just ended up with one answer. Okay? Okay. We have questions.
Yeah.
Okay, we're ready to try 4 then? 4 says 2 sine squared x plus sine x minus 1 equals 0. What are you thinking I'm going to start us off with here?
Product of AC.
Okay. So is this one going to be similar to the last problem?
Yes.
It's all one function. It's all one trig. Like the last one was in terms of cosine. This one's in terms of sine. There's a squared. There's a regular. There's a number. So yes, I am going to tell you to think 2x squared plus x minus 1 equals 0. Logan does say product of AC, and I know that's what you guys demand we go to. Some of you might do, I don't know if any of you do slip and slide, I can't remember there. I'll be honest, I just do a guess and check on this one. And I know, I try and introduce this and no one ever likes it, but I'm going to keep throwing it at you guys. This is a really good one for guess and check because there's only one set of options. It's just a matter of getting the signs. Think with me. 2x squared. For this factoring scenario, how does 2x squared have to break up?
Some form of 2 and 1.
2 and 1, yes? So it's going to have to break into 2x and 1x. Does that make sense? Okay. Now, the multiplying. What's the only option for multiplying to be 1? 1 times 1, yes? I know those are my pieces. It's just a matter, then you just have to get your signs to work out. Now, if you're saying, oh, Mrs. Sargent, I hate this, I can't do this. Okay, product of AC, is it still on the table? Yes, it's still probably the best option because, you know, but I honestly would look at, okay, if this has to multiply to be -1, I'm going to need one of these to be negative. If my outsides and my insides have to add to be 1, then I know I'm going to want 2x times 1 to be positive and the 1 times x to be negative. Now, if that wasn't for you, then by all means, did you product of AC it on the side? Do we need a review of product of AC? Maybe, or were we good on that? Product of AC means I need a what? Product of 2 times -1, so product of -2 and a sum of 1. What multiplies to be -2 and adds to be 1? Positive 2, -1. So 2x squared, split your middle term. I'm going to split it into plus 2x minus 1x. I'm going to carry my -1 down. So carry your first and last terms down, split the middle term. GCF of the first two. What do these first two have in common? A 2x. 2x squared plus 2x divided by 2x is x plus 1. Second, minus x minus 1. What do they have in common? A -1. If you divide out -1, you're left with x plus 1. 2 parentheses. The GCFs of 2x minus 1. And your common parentheses of x plus 1. Okay. I don't know if some of you are saying I didn't need that review, but you got it anyways. Some of you needed it probably. Are we good? Okay. Now, here's the deal. We don't really just want 2x minus 1, x plus 1. Those x's were actually what? Signs. So I'm going to write this as 2, instead of 2x minus 1, 2 sine x minus 1. Instead of x plus 1, sine x plus 1 equals 0. Okay, do we know where to go from here? Set each factor equal to 0. So 2 sine x minus 1 equals 0. Sine x plus 1 equals 0. Solve these. How are you solving 2x minus 1 equals 0?
You end up getting sine x equal 1/2.
Okay. You're going to add 1. So then you have 2 sine x equals 1. You're going to divide by 2. And then we do have sine x equaling 1/2. Sine x plus 1, you're going to subtract 1. And we're going to have sine x equaling -1. Okay. Think through your answers here. Sine x When does sine equal 1/2 according to my chart?
At pi over 6 and 5 pi over 6.
Okay. According to my chart, pi over 6, yes? You're fine. According to my chart, pi over 6. Now, anytime we go to that chart, though, keep in mind, this is when is sine positive 1/2. There's always two quadrants where sine is positive 1/2. Now, we can cheat. Did we already do this problem? We did. It didn't change. But just remember, we're going to need the first quadrant and the second quadrant, right? And so that's how we know it's pi over 6 and 5 pi over 6.
So if you find it on the trig chart, is it safe to say it'll most likely have two answers since there's an all quadrant
And then another positive quadrant, yes. Yeah, that's where a lot of times if you're looking for either the two positive answers or the two negative answers. Okay, now, when does sine equal -1? Did we figure that piece out?
Sorry. Oh,
When does sine equal -1?
3 pi over 2, because the y value is -1.
Are you guys with them on 3 pi over 2? Can I bounce back to my previous screen? 3 pi over 2. When does sine equal -1? Right there, yes? I keep bouncing back to that, don't I? Now, you may want to draw it on each problem so you can see where you're at, but I keep bouncing back to that. That's at 3 pi over 2. Does sine equal -1 anyplace else?
Nope.
No. So in this particular problem, we end up with 3 answers. Okay? Okay, questions I should answer? Okay, well, let's look at number 5. Are you shaking your head at number 5?
Let's go look at it. Let's just stop right here.
Yes.
Nope. Hey, the more I get through today, the more work time you guys get tomorrow. Okay, what's different about number 5?
Two different things.
Okay. These others worked factoring nicely because they were all sines or all cosines.
Stupid.
Okay. We don't have all of one trig function. I did hint at that our identities from the front page of the notes are still going to be important. This is the case that we need to think about the identities because here's the deal. No, I can't really work a problem that has tangent and secant in it. I need it to be all tangent, all secant, all something. I need it to be all one trig function to be able to solve. Okay? So, is there a connection in some identity between tangent and secant?
Can you use Pythagorean identity? Officially, it would be like tan squared minus secant squared would officially be equal to -1, right?
Well, we don't want to do that. Well, we can't. Okay, so here's it. Okay, we can't do a tan squared minus secant squared because we don't have a tan squared minus secant squared. We have a 3 tan squared minus secant squared. Okay, we're just going to replace one of these out.
So we make it 2 tan.
So we're going to take, how is our identity written in the notes?
1 plus tan squared equals secant squared.
Okay, so if we take 1 plus tan squared equals secant squared. If we take secant squared right here, and we replace that with the other part of the Pythagorean identity, 1 plus tan squared, we're now going to have an equation that is all in terms of tangent. And I'm not going to say you couldn't do it the other way with that, make everything in terms of secant, but I'd rather work with one of my big 3, sine, cosine, or tangent.
So it'd be -1 plus 10.
Okay, so I'm going to write this out. 3 tan squared x minus, what am I putting in for secant squared? According to our Pythagorean identities, it is listed as 1 plus tangent squared, right? And I'm putting this in parentheses the first time through because I don't want to lose any pieces of the puzzle here. Okay, you guys with me there?
Yeah.
So 3 tan squared minus secant, but secant became the 1 plus tan squared, and then minus 5. Now, I put it in parentheses there just to make sure we don't lose anything. Keep in mind we're subtracting what's in parentheses. So what does that really mean? Both of those items are going to be subtracted or minuses, right? So I'm going to write it without the parentheses. 3 tan squared x minus 1 minus tan squared x minus 5 equals 0. Okay, guys. Think algebra. Okay. What do you think we would do next? What can we put together?
So it would become like 2 tan squared x minus 6.
Are we putting together like terms? Okay, think like terms. What is 3 tan squared x minus 1 tan squared x? Or it's the same thing as asking what's 3x squared minus 1x squared. Okay. So we're going to have 2 tan squared x. Negative 1 minus 5 is indeed going to be minus 6 equals 0. Like our other problems, we're trying to get, if you think of this as 2x squared minus 6, you'd be working to get the x squared by itself, right? This is 2 tan squared minus 6, so we're going to be working to get the tan squared by itself. So how are we going to do that?
Add 6 divided by 2.
Okay, add 6. So 2 tan squared x equals 6. Then we're going to divide by 2. So now I have tan squared x equals 3. What should be our next step?
You could get to sine and cosine.
No, I don't want to go sine and cosine. Yeah.
You say I know.
If this equation was x squared equals 3, what would you do? You would take the square root. So it's tan squared x equals 3. So what are we going to do? We're going to take the square root. Okay, so we are going to square root here. The square root of tangent squared x is going to be tan x. What's the square root of 3?
Square root of 3.
In an equation setting?
Plus or minus.
Plus or minus square root of 3? So technically,
Oh, gosh.
we have 2 equations to solve here, yes? Technically, you are solving when does tangent x equal positive square root of 3, and when does tangent x equal negative square root of 3. Now, there is kind of some good news here. Okay, go with the basics. What do you know about tangent equaling square root of 3?
Equal to pi over 3 or 60 degrees.
And where did he get that?
Trig chart.
Trig chart, yes? Are you with me? So one answer is pi over 3. Is that the only time that tangent equals the positive square root of 3?
Nope.
No. As we've kind of decided today, there's usually going to be 2 quadrants, right? So we already know pi over 3 in quadrant 1. Where else is tangent going to be positive?
4 pi over 3.
Down here in quadrant 3. And what is pi over 3 past the x-axis? And that is 4 pi over 3. So our next answer is going to be 4 pi over 3. Is tangent positive anyplace else?
Nope.
No. Now we move on to when is tangent negative. So when is tangent negative? That's going to happen in what? Quadrants 1 and quadrants 4. Excuse me, quadrant 2 and quadrant 4. So in quadrant 2, what is my pi over 3 angle up here? What is pi over 3 up from the x-axis?
2 pi over 3.
2 pi over 3. And down here in quadrant 4.
5 pi.
And this is 5 pi over 3 is just right before 2 pi. So my other 2 answers are 2 pi over 3 and 5 pi over 3. Okay? So there's an example with 4 answers. Okay? I told you, it just depends. You have to examine the situation, and it will depend on how many answers you get. Okay? So, tomorrow, we will work on number 6 and figuring that out. We'll talk about 7 and 8, and you should have a little bit of work time. Okay?